All right, everybody, and we are back once again for the daily space weather. Today we'll be talking about why we exist, a solar flare and a solar flare coronal mass ejection watch, cosmic rays, and we would invite you to share the content. First thing we're going to do is look at the sun. Huge series of filaments in the southwestern limb right here. One sunspot, 2804, it's still beta class. It still has a significant potential to produce solar flares. That's right, X-rays. And there still is a possibility for coronal mass ejections. Here's the colorized magnetogram. And sunspot 2804 there has remained rather stable here over the past 24 hours. That's this active area up here. And before we continue on, let me just talk about why we exist. So, you may find that there are other channels that do roughly the same thing that this channel does, and I would beg to differ. We initially started making content just for the fun of it, because we figured other people had this subject matter covered. And it turned out that they didn't. They did not have it covered. They weren't looking at the right information, in my opinion. And they were saying crazy things that were nonsense and made no sense. And that's part of the reason why we started making the daily space weather videos, because we discovered that there was not only a niche, but there was a niche that was absolutely not filled by anybody rational. And so when we saw so much nonsense in the same genre as these videos, we decided to start making our own. So I wanted to talk about the mission briefly. If you want to read more about the mission, head to smashomash.com/forum/mission, smashomash.com/forum/mission. And today I want to talk about number 6, which is to assist mankind by advancing the study of predictive phenomenon to optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is. And that's why we are talking about actual facts here, real science, and observations, not imaginations and complete nonsense. So we're going to show you a couple HelioViewer movies here at the beginning of the video and a couple at the end. Before we do that, I wanted to talk about the electromagnetic spectrum very briefly. The electromagnetic spectrum is a reference to photons. So when we talk about solar flares, we're talking about photons right here in this part of the energy range here. So 10 to the 18 hertz, and the area around that region, that's known as X-rays. This is what a solar flare is. It's completely different than a coronal mass ejection. A coronal mass ejection is molecular matter being blasted out of the solar corona. A solar flare is the emission of photons in the X-ray spectrum. So you're only able to see this little portion of the electromagnetic spectrum, and it goes all the way from very low, very, very low frequency radio waves. And this graph is showing you all the way down to 10 hertz, so 10 vibrations per minute, and then all the way up to gamma rays and cosmic rays, up to 10 to the 24 hertz. So a 10 with 24 zeros after it, vibrations per minute. And here's a portion of that. And when we look at these images like this is 193 angstroms. That is a reference to the actual distance between the photon waves that is in this portion of the electromagnetic spectrum. A very small little slice of it, only 193 angstroms. It's part of the emission spectra of ionized iron, and different chemicals emit different wavelengths depending on things like how many electrons they have and so on. So without going further into that, here's 193 angstroms. You see this large coronal hole in the southern hemisphere. Just moving into the Earth-facing zone, you can expect to see a coronal hole wind stream from that here at Earth in about 3 to 4 days. We did see a B 9.5 class flare come out of this active region. And once again, the potential for more significant flares coming out of this sunspot 2804 remains. So here's 94 angstroms. We already showed you that in the SDO browse data. It looks a little different on HelioViewer. And here's a close-up of the solar flare that happened just as I woke up this morning. And thanks once again, Sun, for producing activity just at the right time. Making it convenient, it seems like you're promoting the channel. So cheers. Cheers, El Sol. And here's another view of that same region. It's 131 angstroms. And both the previous slide and this one are different emission spectra of iron, because an iron nucleus wants a lot of electrons. And in different states of ionization, in other words, a different number of electrons in its shells, it produces spectra at different wavelengths. So this is 131. The last one was 94. Great view of that nearly C-class solar flare there, right at the end of the 24-hour video. And there's that solar flare. Here's another view. It's 193 angstroms. We showed you this earlier. This is good at showing coronal holes. And it also shows filaments. You can see a bunch of filaments in this area right here, which once again do have the potential to produce coronal mass ejections. They have the potential to eject out of the corona. And we'll show you 171 angstroms as well, another UV emission spectral state of ionized iron. Fantastic view of that. And we've got close-ups of sunspot 2804 as well. By the way, this region here isn't even a sunspot. It's only a plage, still capable of producing X-rays. So we'll show you that at the end of the video here. And let's continue on with some more data, such as the location of things in the solar system. Here's where planets are located. And hey, happy full moon. It looks like full moon is coming tomorrow. And there's where we expect things to be in a week. I like to use in-the-sky to make my star charts. If you're interested in what's overhead, check it out, in-the-sky.org. Put in your location. You can make your own star chart. I face mine to the south, and I draw in the ecliptic. As in the northern hemisphere, your ecliptic is to the south, and you may see the moon setting if you're up before dawn. The radio flux now down to 80 solar flux units, excuse me. 10.7 centimeter radio flux at 80 solar flux units. And here is the 1-year chart of that to put it in context. Once again, back out of solar minimum conditions. It's the black line there near the top of the graph. And there it is through cycle 24. Welcome to cycle 25. And next we'll look at volcanoes, as we're not only interested in solar eruptions, also earthly ones. So Mount Abico on Paramushir Island, producing a 10,000-foot ash plume. Raung on East Java, exploding. Flight level 130, it's a 13,000-foot ash plume above Mount Raung. Mount Ibu, located on Halmahera in Indonesia. Flight level 070, it's a 7,000-foot ash plume. We've got 2 volcanoes in Guatemala, both exploding. Pacaya and Fuego are producing an 11,000 and 15,000-foot ash plume respectively. Sangay in Ecuador, as well as Revenador, they're both exploding as well. 19,000 and 14,000-foot ash plumes respectively from those calderae. And Sabancaya in Peru also exploding, producing a 23,000-foot ash plume. Leave us a comment if you'd like a shirt that says, "Please don't pole vault the caldera." It's already in the works. Next, looking at earthquakes over the past 24 hours. We don't see any major earthquakes. Let's scroll up the list real quick. Don't want to spend too much time on things that aren't so exciting. So not a lot of quakes here. One deep quake here striking in central South America, actually, quite far from the coast there at Argentina. Let's check out the location of this one, as it's at 570 kilometers, and it's east of the Andes. And there's a location of that. A 4.2 magnitude quake at 570.3 kilometers depth. Another deep quake struck Fiji in the last 24. It's a 4.7 at 550 kilometers. Otherwise, low levels of earthquake activity. I'll tell you what's groundbreaking. Our own website. We saw the writing on the wall years ago, so we created our own website, smAsho.com. smAsho.org will redirect you. You can find all of our contact information and so on there, as well as links to our store. Today's product is the Smashes of Hazard. Yes, you may have noticed our theme song, the Smashes of Hazard. And shout out to Henry and Al, otherwise known as Mr. Keebler. Don't forget to subscribe to their channel on YouTube, Mr. Keebler, who helped us with that, provided the background music for the Smashes of Hazard. So perhaps check out some merch. You can link to all of our merch. There are 3 different shops there at smAsho.com. That one was the smAsho merch. There's also a smAsho store and the Smash store. You can also link to the forum there, the smAsho forum. And again, if you want to read more about our mission, just head to smashobash.com/forum/mission. By the way, this is actually streaming live to Twitch right now, and we often record our daily space weather videos on Twitch because it's such a great live streaming platform, and we want to put our content in as many places as possible. Twitch.tv/smashamash. They've got a great mobile app as well. Thanks to our followers over there. We don't always stream, and we do actually stream to YouTube as well on the regs. Make sure you check out our exclusive content on all of our different locations. Please don't forget to press like and subscribe if you're a YouTube subscriber. Thanks to our new subscribers over at YouTube. Cheers. We greatly appreciate your pressing like, pressing subscribe, sharing with your friends and foes on social media. Thanks to everybody that does that. We're also on BitChute, bitchute.com/smashomash. Also, if you've seen our business card anyplace and you've picked it up and you're here as a result of seeing that business card, let us know in the comments, as the marketing has changed, and it will continue to change. Nothing will remain the same on the channel. Let's do a cosmology segment. Today's will be brief. Yesterday's was less brief, and maybe check out yesterday's cosmology segment, as it includes very, very important information about the structure of astrophysical jets. I won't tell you any more. There's a teaser. Astrophysical jets featured in yesterday's cosmology segment, and look for another one coming out, a standalone video coming soon about that. Our patrons already have a little bit of information about it. More on our patrons later. Let's pick a random number between 1 and 1031 to coincide with an object at the Neil Gorell Swift Bat X-ray Observatory. It stands for Burst Alert Telescope. Today's number is 124, which is PKS 0347-211, a quasar, which is a galaxy with an active galactic nucleus, and it's active because we're looking straight down the poloidal field of it. We're looking perpendicular to the galactic disk of this galaxy, most likely, although it could be an elliptical. In any case, here are the X-ray emissions of quasar PKS 347-211, and we'll take a look at it on Simbad and look at it in a couple different wavelengths here on Aladdin Light. It's going to look like almost like a star, a single point of light. And there you can see it's quite dim, an indication that perhaps it's very distant without doing additional information on that. Here it is in infrared, and it must be in a deep space portion of the sky, not on the galactic disk at all, barely even showing any kind of a signal in infrared. Let's check it out on the XMM Newton, the multi-mirror project. Not there. How about on Chandra? Not there either. Does it show up in visible light? And you can see a little bit of a bright spot there in the visible spectrum. It's quasar B0347, otherwise known as PKS 347-211. We've got one more segment in today's cosmology segment. We're going to do a report on cosmic rays. So since cosmic rays are super important in terms of the Earth's climate, yes, climate, cosmic rays make the planet cloudier, folks. They create ionization pathways in the Earth's atmosphere, especially in the lower portion, the troposphere, in which you live. Those ionization pathways create cloud nucleation. Those ionization pathways create cloud nuclei, and they make the days cooler and the nights warmer. Yes, the greenhouse effect is real, folks, and it's almost entirely caused by water vapor. If you've noticed cloudy nights are warmer, that is because heat is being held in and re-radiated by water vapor and clouds. Located overhead, cosmic rays have a tendency to make the planet cloudier, as discovered by the Svensmarks in 1996. It's fairly well-known science nowadays, and it's really not in current climate models. Without further ado, here is the cosmic ray report. The Apatity neutron monitor showing a downward trend over the past 30 days. Barentsburg, a downward trend as well, although some spikes in the past couple days. Overall, downward over the past 30. No surprise there, as solar activity increases during cycle 25. Now going farther south to Athens, there's the Athens neutron monitor, and you can see once again a decrease in cosmic ray flux over the past 30 days, and for that, we thank you. Now going even farther south to Mexico City, a little flatter graph, but also a downward trend over the past 30 days. And let's go back very far north, and then even farther south at Oulu, Finland. Downward trend at Oulu, Finland over the past 30 days. And let's look at DOMB Antarctica. There's DOMB Antarctica. Slight downward trend at DOMB. And DOMC, also a slight downward trend there. And once again, for that, we thank you. By the way, don't take our word for it. Just do a search for links to cosmic ray data, and you will find that site. The network of cosmic ray stations. And that's today's cosmology segment. Since all your weather comes from space, I figured I would talk about it briefly. Here's that X-ray flare that happened. It's a B-class flare. A B 9.5, so not quite a C-class flare, but the largest solar flare we've seen in quite a while. That's a 3-day chart of the GOES 16 X-ray flux. Proton flux remains flatlined here. We show it daily because when things like coronal mass ejections actually strike in a significant fashion, you'll see spikes in this. We haven't seen any for months. Next, looking at the real-time solar wind. Give it a minute to load. It's well worth it. And I'm going to actually press refresh. It looks like we've got some missing data at the end of the graph. Most current data showing, oh, that's current. That's current enough. Current solar wind density, 3.39 protons per cubic centimeter. Current solar wind speed, 401 kilometers per second. Back to background conditions, folks. That is a calm solar wind. Solar wind now chillin', and it's brought the KP index back down to 1 after repeated periods of geomagnetic unrest caused by a lengthy and powerful coronal hole wind stream. And for you new viewers, the KP index is a measurement of global geomagnetism. Again, current KP index is at 1. Next, looking at the magnetohydrodynamic pressure in space. This is 4 hours of data, and it is the magnetohydrodynamic pressure measured in nanopascals. So this is the magnetism, and you can see the main aspect of magnetohydrodynamic pressure here located in the magnetotail region, the area in between Earth and Lagrangian point 2, the area behind the Earth, the opposite side of the Earth with respect to the Sun. No surprises there, as the solar wind has subsided in both density and velocity. Here are ground magnetic perturbations. We show this daily as well since we're living through a polar excursion, a geomagnetic excursion, folks. Will a magnetic reversal happen? No. Will a magnetic reversal happen? Probably not. In all likelihood, no. But in any case, Here are the 4 hours of magnetic perturbations. I'll let it play through a second time because the Earth currently has 2 geomagnetic north poles. One someplace over here, over northern Canada, and one someplace over here, over Siberia. And the South Pole is someplace down here in the Indian Ocean, thousands of miles away from the South Geographic Pole. Here's the 3-day chart of the GOES magnetometers. Earth still in the South Pole current sheet. We'll show you that on the next slide. If you're wondering what these arc jet moments are, those are the GOES 16 turning on its thrusters, which can affect the magnetometer readings in that they put plasma in the area of the magnetometers. The GOES 16 tries to maintain its location at around 300 kilometers, and occasionally it has to use its thruster engines to do so. Here is the current sheet, the heliospheric one. So it's as if you're looking at the sun from the North Pole, and this is showing you the polarity of the current sheet as the solar wind is oriented to one or the other. So Earth currently in the red one, which is South Pole oriented. Just keep in mind the data is 1 hour and 27 minutes old, can change with absolutely no warning. And if I had to guess, and I don't, but I will anyway, I would say the Earth will probably still be in the South Pole current sheet tomorrow when we make the daily space weather video, although there is a North Pole current sheet coming. We'll let you know when it happens. Here's a line of sight field plot. It shows you the sun's B field in blue and the poloidal fields as well. It also shows you a solar magnetogram. The next slide will show you the coronal hole field plot. And you can see that Earth-facing South Pole-oriented coronal hole there in red. Again, expect a coronal hole wind stream from that in 3 or 4 days. Here's a magnetic field plot of the solar corona, the sun's chaotic atmosphere. And it'll show you open potential field surface source lines in black or purple, depending on their location, and closed ones in pink. No major changes going on there. Here's a diagram of the atmosphere. If you need to pause this, please do. We'll be here when you get back. Here's another diagram of the Van Allen belts and the altitudes of spacecraft and so on. Again, feel free to pause it if you need to gather more information. Now we're moving into the realm of electrons, and we don't see that warning level of electrons that we've been seeing the past couple of days. Electrons have chilled out as well. We don't see any charging hazards for spacecraft at the current moment. Here's the 3-day chart of the GOES electron flux. This area here was about 22 times the warning levels. Now we're back into fairly normal modes. These N's and M's, for you new viewers out there, refer to noon and midnight local time for the GOES 16. Here's a 1-year chart to put that in context. You can find that yourself at solon.info/solar. Solon.info/solar has a link to the 1-year relativistic electron flux chart. Here's the forecast. No complaints here. The yellow diamonds are not Lucky Charms cereal marshmallows. Those are the observed electron flux data. The green squares are the forecast. I have no reason to refute this forecast. Here's a visualization of the total electron content. This will show you electrons all the way from a GPS satellite down to your handset. And we do see major errors here once again, likely to be happening over places like northern South America, the Central Pacific. I'll let it play through a second time. When you see that turn red, that is major GPS errors happening. And GPS errors are most common around the equator at noon. This will subside throughout the day today, most likely. Here's an ionospheric map. Now we're looking at just one slice of the ionosphere, and this is in megahertz. I'm seeing this for the first time myself. Oh my God! Just kidding, folks. It's looking pretty normal so far. Nothing too exciting happening there, although we are approaching the spring equinox, and we can expect to see a little more anomalous behavior of the ionosphere around the equinoxes as the incoming solar radiation and particles produce a more perpendicular strike on the Earth at times of the equinox. Anyway, there's the latest image at 10 o'clock Universal Time. Next, we'll do some meteorology stuff. Here are the jet streams of the eastern world. And just let me check the life of the stream here real quick. And everything looks just fine here at the Smash News Network. Least busted name in news. This is the 250 hectopascal winds. If you're new here, it's on nullschool.net. And we see the jet stream blowing backwards once again over the western Pacific Ocean, as well as part of the Indian Ocean. It's not very strong, but it still is backwards. And we see some tripled up jet streams here in the southern hemisphere, doubled up jet streams in the northern hemisphere. Some extreme meridional jet stream flow here over the Pacific Ocean, as well as some backwards portions once again, very kinked jet streams here. We show it daily on the Daily Space Weather because this is part of the point of these videos is a data archiving service. And if you had to look at only one variable to make global scale weather forecasts, the jet stream would probably be your best choice. We see a slight increase in lightning here. We have about a week-long lull in lightning on a global perspective. Very low levels of lightning. But now we finally see some terrestrial lightning in the U.S. Let's throw out a warning. Hey, Shreveport. Hey, Texarkana. There's a thunderstorm south of you. Hey, Dallas. Shout out to Glenn Beck, Pat, and Stu. Leave us a comment if you're watching the videos. And if you're on a skyscraper, go out and look to the east. You may see some interesting phenomena like sprites or green elves or other weird stuff going on above these thunderheads. They're pretty significant. Thunderstorms just to the east of Dallas, and most likely you're out of the crosshairs most of Dallas. Lake Tawakoni, there's thunder rolling in. I like to use lightningmaps.org to convince my friends and my foes that I'm Thor and that I'm causing the thunder and lightning to happen, not just forecasting it. The next thing the Smash News Network is going to show you are pressure cells. Here is the pressure environment, the environment of atmospheric pressure. Significant anticyclone here in the northern Pacific off the coast of California, as you can see right there under my pointer. Clockwise rotating systems in the northern hemisphere are what we call anticyclones, which are the real input into the atmospheric phenomenon. Yes, high pressure is very important to global weather patterns. I know people pay attention to low pressure systems because that's associated with precipitation, but the high pressure is really the input. We're going to advance this into the GFS forecast. There's the GFS forecast for where we expect pressure cells to be at 1 p.m. Eastern Time tomorrow. And it looks like that pressure, it looks like there's going to be a building pressure here in the Pacific Ocean. It's a double system, really. Once again, there is the pressure, according to the GFS forecast, at 1 p.m. Eastern Time. Next, we'll look at the cloud layer. And there's what's going on in the cloud layer. Here's the water vapor map. Some major moisture there over northern Minnesota especially. And it looks like it's going to move a little bit to the north as it heads east, as there is dry, massive air to the south of it. And for you new viewers, dry air and cold air are both more massive than moist, hot air. Let that be a lesson to you, a meteorological one. Here's the U.S. Doppler radar map. And oh my God, Check out those thunderstorms stretching all the way from Texas to south to Georgia. Let's go back to the water vapor real quick. Those look like they're going to continue on their same trajectory in an east-northeasterly direction. A little bit of ice storm showing up on the Doppler radar there in northern Virginia, as well as some snow falling in northern Virginia and Maryland. Hey Smash team, thanks for tuning in. Don't go anyplace, we've got bonus features. Once again, don't forget to press like and subscribe if you're viewing on YouTube. And thanks for leaving a comment, Kathy Garden. Kathy Garden says we are about to get hit with big storms. Make sure you put on your helmet, get your kayak ready, get your bilge pump primed, and so on. Press like and subscribe if you're viewing on YouTube. Thanks to our BitChute viewers as well. If you're viewing on YouTube, please press share, press subscribe, press the notification bell so you know when we put up videos. Here come bonus features. They're going to come in the form of a high resolution. Oh, wait. Well, I'm told there's one other feature we must cover here. And that is thanking our patrons, the true source of funding for the content. Thanks to our patrons. You can become a patron at patreon.com/smAsho. You get all kinds of updates before anybody else, alerts, etc. Thanks, patrons. Patreon.com/smAsho. Patreon.com/smAsho. Do it. Do it now. And here come the bonus features. The high-res magnetogram and the high-res intensitygram. Here's a close-up of sunspot 2804. It's got a very large leading umbra. It's still beta class. It looks like the trailing umbra has actually degraded a little bit. Still is a significant possibility for additional solar flares. There it is in colorized magnetogram. And you can see the trailing umbra is indeed South Pole oriented, which is what makes it a beta class sunspot. And we've got several more Helio viewer videos for you here. Actually, make it two. I didn't put them all in the daily space weather video today because we don't want it to be too long. So here's a close-up. This is actually a composite image of sunspot 2804. This is 171 and 94 angstroms, which is why it has that chartreuse color. Two different wavelengths there. Great close-up of that sunspot group. And we'll close things out in 171 angstroms with a full disk image. It's a 24-hour, approximately 24-hour full disk view of the local yellow dwarf. Thanks for stargazing. Remember, stare at the sun, attempt to understand the physics. And when you're attempting to understand the physics, don't drink. And if you do, don't drive. Since it'll never be now again, by the way, may that solar wind be at your back and that nonsense absent from your YouTube feed. An unlikely possibility.